Today we're going to be in the Unit 5 packet called Exponents and Exponential Functions. And today we're going to be on page 14. All right, today we're going to be looking at some word problems where we can use our exponential growth and decay formulas to find whatever the problem is asking us. So on page 14, we're going to talk about exponential growth. So the formula is y equals a, parentheses, 1 plus r to the t power. All right, a stands for the initial amount. R stands for the growth rate. And T stands for time. All right, so we're going to be using this formula to do these examples, and you are going to need a calculator because once we plug it into the formula, you're just going to simply type it in your calculator, press enter, and it's going to give you an answer. So, number one, the original value of an investment is $1,400, and the value increases by 9% each year. Use an exponential growth function to find the value of the investment after 25 years. So the first thing I need to find is my A, my R, and my T. All right, so A is the initial amount, which it tells us in the problem, okay, the original investment was $1,400. All right, our R value is our rate, okay, so that's our percentage, which is 9%. All right, but when we do percentages for the formula, we want them in decimal form. So I'm going to do 9 divided by 100, which gives me 0.09. And this is what we're going to plug in for R in our formula. And then T is time, which it asks us, or it tells us to find the investment after 25 years. So that's our time. So now I'm going to plug my values in. So for A, I'm going to put 1,400. For R, I'm going to put 0.09. And for T, I'm going to put 25. All right, now you can plug all of this into your calculator, just like we have it written down. All right, and when you do that, you get $12,072.31. So after 25 years, okay, they have made a lot of money. Their investment went from $1,400 to $12,000. But 25 years, that's a long time. Like, I'm 25 years old, so my entire life, my investment went from $1,400 to $12,000. All right, let's do number 2. The cost of tuition at a college is $12,000 and increasing at a rate of 6% each year. Use an exponential function to find the tuition after 4 years. All right, so A is our initial amount. All right, so the tuition for college is currently at $12,000, but it's increasing. So that's our initial amount. Our rate is our percentage, which is 6%. But I'm going to turn that into a decimal. So I'm going to do 6 divided by 100, which gives me 0.06. And then time is 4 years. So now we can plug this into our formula. So our A value is 12,000. Our R value is 0.06. And our T value is 4. So now you can plug all of this in. Well, I tried. You can plug all this into your calculator just like you see it, and it's going to give you $15,149.72. All right, let's do number 3. The number of student athletes at a local high school is 300 and is increasing at a rate of 8% per year. Okay, so we know our initial amount, we know our rate. Use an exponential function to find the number of athletes after 5 years. So now we have our time. So A is 300, R is 8%. So I'm going to do 8 divided by 100, which is going to give me 0.08. And then T is 5. So I'm going to plug this into my function. A is 300, R is 0.08, and T is 5. So I'm going to plug all of that into my calculator. And when you do, you get 440.798. All right, but thinking about the problem, we're talking about people, and we can't have a decimal of a person. So we would just drop the decimal, and our answer would just be 440. All right, number 4. We have an annual sales for a company are $149,999 and is increasing at a rate of $6,000 per year. So we have our initial, we have our rate. So now we're going to use an exponential function to find the sales after 7 years. So now we have our time. So A is 149,999. Our rate is 6%, but I'm going to do 6 divided by 100 to get it in decimal form. And then T is 7 years. So I'm going to have 149,999 parentheses 1 plus 0.06 to the 7th power. So I'm going to type that in my calculator, and I'm going to get $225,543.04. All right, number 5, the population of a small town is 1,600 and is increasing at a rate of 3%. So we have our initial, we have our rate, and we're going to use an exponential function to find the population after 10 years. Okay, so when I plug that in, I'm going to have y equals 1,600, parentheses 1 plus 0.03 to the 10th power. Okay, remember, we're talking about people, so when I type this in, I get 2,150.266. Okay, but we're talking about people. So I'm going to drop the decimal, so it's just 2,150. All right, number 6, in 1985, there are 285 cell phone subscribers in Mayville. The number of subscribers increased by 75% per year after 1985. So we have our initial amount of cell phone subscribers, our rate, and we want to find the number of subscribers after 2008. So they don't give us a set amount of years this time, but we want to figure out how much time has passed between 2008 and 1985. So A is 285. R is 75%. So I'm going to do 75 divided by 100 and get 0.75. And then T, I'm going to do 2008 minus 1985. And that's going to give me 23. So when I plug this in, I'm going to have 285 parentheses 1 plus 0.75 to the 23rd power. Again, we're talking about people, talking about subscribers of this cell phone plan. So when I type that in, I get 110845988.3. So we're just going to drop that decimal. So we'd have that many subscribers, which is 110,845,988. So wow, in 23 years they gained a lot of cell phone subscribers. All right, let's look at the back. Now we're going to look at decay, which the formula is the same, except now we are subtracting instead of adding our rate. All right, so A is still the initial. R is still the rate, and T is still time. All right, number 7. The population of a small town is decreasing at a rate of 1%. In the year 2000, there are 1,300 people. And we want to use the exponential function to find the population in 2008. So A is 1,300. R is 1%. So I divide it by 100 and I get 0.01. And then T, they don't give us a set amount of years, so I have to do 2008 minus 2000, which gives me 8. So I'm going to have y equals 1,300, parentheses 1 minus 0.01 to the 8th power. So I type that in, and I get 1,199.568. All right, we're talking about people. And since we're talking about a population of a town, okay, we're not going to have a decimal. So we're just going to drop the decimal. All right, number 8, the value of a car is $18,000 and depreciating at a rate of 12% per year. So depreciating means decrease. You may see that on some assignments or tests instead of saying decrease, so just be aware of that. Use the exponential function to find the value of the car after 10 years. So our A is 18,000, our R is 12%, which would be 0.12. Then our T is 10. I'm going to have y equals 18,000, parentheses 1 minus 0.12 to the 10th power. So I'm going to plug that in my calculator, and I'm going to get $5,013.02. All right, number 9, a farmer buys a tractor for $50,000. If the tractor depreciates at a rate of 10%, we want to find the value of the tractor after 7 years. So A is 50,000, R is 10%, which is 0.10, and then T is 7. So I'm going to have y equals 50,000, parentheses 1 minus 0.10 to the 7th power. And I get $23,914.85. All right, number 12, an investment of $8,200 loses value at a rate of 2% per year. Use an exponential function to find the value after 9 years. So our initial is 8,200. Our rate is 2%, which is 0.02 as a decimal. And then our t is 9 years. So when I type that in, I get $6,836.73. All right, I want you to pause the video and do 11 and 12 by yourself, and then come back and check your work. All right, so there's the answers to 11 and 12. Make sure you check your work, and that completes the notes for exponential growth and decay functions.